So as Galen alluded to, going to talk primarily about just backgrounding or growing diets. And so growing diets can be as varied as producers or cattle going through those programs, right? I've got a few pictures. They can be out grazing, whether that's wheat pasture, brome grass, native range, or maybe dormant residues in the wintertime. So that could be corn residue, it could be dormant range. Whole lot of different scenarios if you're growing cattle. But specifically today I'm talking more of a pin situation. So if we have cattle pinned up and maybe are feeding them corn silage, we think that's a pretty good fit for some of these backgrounding calves. Already been talked about a little bit, but some data. So everything I'm presenting today was, the legwork was done by graduate students. We have quite a few in the room today and some past ones as well that were all very important in collecting this data. So I just stand up here and present it, but didn't get involved in collecting a lot of this data. And so this was done by Cassandra Rao several years ago, looking at how much forage and how much grain is there in corn silage. And so hybrid and all of these things, cutting time can all affect that. But she found here, so weeks from black layer, 4 weeks before black layer, all the way up to 3 weeks past black layer, and you can see how that percentage of grain changes. So this is percent grain, and really we're right around that 50-50 blend, right? 50% grain, 50% forage. And that's really great from a feeding standpoint, right? We've got this excellent feed that's 50% grain, 50% forage. The challenge comes in knowing the nutrient content of that feed. And so one of the big challenges that we found with corn silage is actually analyzing it for these nutrients because it's a forage and grain blend. So most of our lab techniques are specific to either forages or grains, interestingly enough. Corn silage is a blend of both. I thought it was interesting. You said a lot of times you deal with the corn silage separately, the forage and the grain separately, and we're starting to do the same thing because a lot of our techniques just don't work on the blend very well. The other thing, when you're trying to find out the nutrient content of your corn silage, it's such a moving target because of the ensiling time. How long has it been in the bunk will actually impact a lot of the nutrient content, especially what I'm going to focus on today, which is the RUP, the rumen undegraded protein in that corn silage. It's constantly changing, actually. The final component that can be a challenge with corn silage is the dry matter content when it's harvested, because that moisture content actually, again, affects how digestible the protein is within this corn silage. So this was some work Josh Benton did back when he was in grad school. He's been out for a few years now, but looking just at high moisture corn. So we're going to take just this high moisture corn and compare it to the corn grain within corn silage. And so he had 3 different levels of moisture. So the grain was either 28, 30, or 35% moisture. And then the grain was ensiled for either 0 all the way up to over a year, 392 days. And you can see the RUP content, so that undegraded protein, so that protein that does not get broken down in the rumen, instead bypasses the rumen and can be used by the animal, absorbed out of the lower tract there, that portion of protein decreases basically linearly with increased days in that bunker or ensiling days. The other thing, the wetter the corn grain, the less RUP you have, okay? So that protein, when the corn silage is wetter when it's put up, and the more days it's in that bunker, the less undegraded protein you have, so the more digestible that protein is. Goes right along, again, first talk this morning, we were talking about the digestibility of the starch, same thing, just talking about the protein component now. A follow-up study then, so that was just corn grain, and we got up to 35% moisture. But we think that the moisture content of the grain within corn silage is actually quite a bit wetter than that. The grain within corn silage can be upwards of 50% moisture actually, because your whole silage, right, can be 65% moisture very easily. And so here, this is the wettest that we were able to get. The grain component was 50%. And so again, just reiterating that same story, if the red is the driest corn grain at 25% moisture, and the blue is the wettest at 50% moisture. In every instance, we see a linear decrease in the amount of undegradable protein as the moisture content of that grain increases. The other thing from this slide then, days that it was ensiled, 30, 90, 180, or all the way up to 270 days. Again, the amount of RUP within that corn grain decreases with that longer ensiling time and is most dramatic with the wetter corn grain. So that grain that's most similar to corn silage is where we're really seeing this effect. So you need to know what kind of values do I use for corn silage. We've heard a couple times book values just really don't cut it very well. So we tried to look at in situ incubation of corn silage in order to get to the RUP content of it. And we broke it down separately into forages and concentrates, so the forage portion versus the grain. Some differences in the techniques: forages, microbes attached to them. Microbes have nitrogen, they have, so then when you analyze for crude protein, it's off because of all the microbial attachment. So you wash them with neutral detergent solution. You don't do that with the grain, because there will be some protein there in the grain that will be solubilized by the neutral detergent solution that you don't want to lose, but there's less microbial attachment because they have less NDF there. So just different techniques that we used in order to put it together. We came up with this value from the corn grain and from the forage, put them together, about 0.72% of dry matter on this corn silage as RUP content. What does that mean? So your corn silage is going to be variable, right? The crude protein content of it's going to be variable. The digestibility of that RUP is going to be a little bit variable. But really, our take-home message, our recommendation right now, approximately 90% of the crude protein within corn silage is rumen degradable protein, okay? So that only leaves 10% that's rumen undegradable. Some of that's going to be indigestible. So it's essentially zero. Not quite, but it's pretty close to zero RUP content of corn silage. This would be, if 90% of it is RDP, that leaves a little bit less than 1% of the dry matter as RUP. So the NRC book values, even the newer nutrient requirements of cattle, all these books typically have 72 to 75% of crude protein as RDP, and we're saying it's closer to 90. Now I just want to go, so you've got to know what's in your corn silage, right, in order to accurately formulate rations, include those nutrients that you're missing in order to get the performance that you're wanting for these growing calves. So I have just a series of pin studies here that kind of underlies just how important RUP is in these growing studies with the growing calves having such high protein requirements. So this is the oldest one done by Jeff Fulmer, published back in 2002. It was 128 steers fed in 16 different pins for 100 days. So it was a 90% corn silage diet. The remainder of the diet was supplement, which was 6.5% soybean meal and a little bit less than 1% urea. Okay, so corn silage, a little bit of soybean meal and a little bit of urea. Those calves started out at about 600 pounds. They ended at just over 900 pounds in 100 days. So they were gaining just under 3 pounds per day. And feed conversion was just over 6 at 6.33. Okay, so now fast forward a few years, and Barry Weber did a study, again, growing study, 240 steers starting out at about that 600 pounds, so similar in weight, 86-day growing trial, 80% corn silage with 15% wet distillers in the diet, and just a little bit of urea in there as well. Okay, ending body weight 924. So started out about the same weight and ended about the same weight as the Fulmer study, but it took fewer days to do it, right? Only 86 days. So their average daily gain now was over 3.61 pounds per day, eating over 20 pounds, almost 21 pounds, for a feed conversion of 5.75. Very similar study done by Hilscher, so Henry Hilscher would be in the room. He did this one more recently, 216 steers with 18 pins. Again, starting out at about that 700-pound range, 76-day growing trial now. Very similar diet, 80% corn silage, 15% modified distillers this time, and again, just that half or 0.6% urea in the diet. Ended at 989 pounds. They ate over 21 pounds a day and gained 3.62 with a feed conversion of 5.86. So these calves are doing quite well on what I think would be a very high inclusion of corn silage. And finally, Lauren Oving is in the room as well. A most recent study that we have with growing cattle with high corn silage diets, 288 steers, 36 pins, 70 days that they were grown. This one was a growing trial where they immediately transitioned to finishing. And so these would just be one-day weights shrunk 4% in the middle, where the other ones were truly growing trials where they were limit-fed and weighed 3 days at the end of them. This one was 75% corn silage with 21% modified distillers and 0.75% urea. Ending body weight, so these came in right at 700 pounds and ended at 991 at the end of the growing phase. They again ate right around 21 pounds per day with a gain over 4 pounds per day on this one, and a feed conversion then under 5 at 4.98. So I'll go ahead and combine all 4 of those, right, so that you can see them on one slide, maybe compare a little bit better. Obviously, these are all 4 different trials, so we can't make clear comparisons between them, but just to look at them all on the same slide, we can see here 90, 80, and 75% corn silage, so decreasing that amount of corn silage just a little bit while increasing the amount of distillers, so 0, 15, or 21% distillers grains really complements that corn silage really well, it seems like. Crude protein of the diet increased from about 12.5 up to 15 as we increased that distillers in the diet. But more importantly, the RUP content of those diets increased. So it was 2.24 in the 0 distillers diet. So RUP is a percent of dry matter in the diet, all the way up to nearing 5%, 4.76% of the dry matter as rumen undegradable protein. And linearly increased average daily gain, I would say, along with that, right? So average daily gain anywhere from about 3 pounds upwards of 4 pounds per day, with feed to gain improving as well. I'm not saying any of these are the ideal situation. I'm saying that's a pretty big range in average daily gain or feed conversion. And so you can kind of look at feedstuffs that you have on hand and gain that you want calves to get to whatever weight they need to be, and kind of target an average daily gain based on that. As long as you understand the importance of balancing diets for metabolizable protein and looking at the rumen undegraded protein content of these diets instead of just crude protein. So there's 2 studies that I'm going to explain here a little bit that I think really delve into the issue of just formulating on a crude protein basis. Okay, so this first study was done by Felix and others, published back in 2014. So this one, again, I said those last 4 studies were not all in one, right? We can't directly compare them. This was one study with different supplements, similar to what I was just showing, but this is all within the same study, so now we can do statistical comparisons. 79% corn silage diet with 18% dry distillers, or 9% soybean meal, or not quite 1.5% urea. Okay, so different forms of protein supplementation in a high corn silage diet to growing calves. They started out just under 600 pounds here, so a little bit smaller, and ended at 887, 878, or 838. So the distillers and the soybean meal supplementation actually had very similar ending weight, very similar average daily gain, and very similar dry matter intake. So they gained about 3.4 pounds per day and ate about 16 pounds per day. The calves receiving the urea as their protein supplementation, they were smaller at the end of the 84 days. They gained less per day, so under 3 pounds per day, and they ate less per day for a poor feed conversion, right? So you can get similar performance with the distillers versus a soybean meal, but as they pointed out in this paper, the cost of gain was quite a bit less at this point for the distillers grains treatment compared to buying soybean meal, right? Okay, the other trial from this paper looked at simply, I wanted to make sure and point out here, crude protein of these diets were essentially all the same, right around 10.8% of the diet. Same crude protein in all of the diets. So what happens if we have a 90% corn silage diet, calves, pretty small calves here, just over 400 pounds, but we increase crude protein here, almost 13% crude protein all the way up to almost 15.5% crude protein, but do that with urea. So urea as a source of protein coming in at 1.37% of the diet, all the way up to over 2% of the diet. Okay, so you've got the protein there. What happens to performance? Ending body weight, they actually were smaller with the higher crude protein diet, right? They don't have the right type of protein in these diets. Dry matter intake was a little bit less. Average daily gain went from over 2.5, 2.66 with the low level of urea to 2.3 with the high level of urea. And feed conversions linearly increased. So feed conversions were worse as we increased the urea in the diet. So simply elevating the crude protein of the diet will not get you to the performance that you're hoping for. So it's really all about the type of protein that you're supplementing. And it seems right now, when you need a source of RUP, that distillers is maybe the most economical source right now and fits really well with high corn silage diets. However, with distillers grains, it's both energy and a protein source, right? It's really hard to break those two things apart when you're feeding distillers grains. It's an excellent source of both types of nutrient. And so we did 2 iBarn studies. So they're done just down the road here in what we call our individually fed cattle barns. So we had 60 head on each trial. So it's a total of 120 calves that were individually fed corn silage along with a supplement that supplied rumen undegradable protein. Okay, so it was a supplement that consisted of soy pass and imperial. They're both very concentrated forms of protein. So soy pass would be processed soybean meal basically, and so it's 50% crude protein, 75% of that is rumen undegradable. And then the other source would be from corn, so it's imperial, which would be a product out of Cargill up by Blair. 75% crude protein, 65% of which is rumen undegradable. So a blend of soybean and corn proteins basically to supplement these calves without the quite as high of energy value as we would see with distillers grain. So it's a really concentrated form of protein. So the calves were fed either 88 or 85% corn silage with these graded levels of RUP supplement. As you can see, average daily gain quadratically increased, so I just went ahead and put the dots on there. So the triangles are one trial, and then the circles are the other one. If we combine the data and look at it, it is a quadratic increase in average daily gain, with maximum average daily gain here at what would be 3.2% of the dry matter of the diet as rumen undegradable protein. Okay, so that would be similar to having just over 15.5% distillers in that diet. So kind of 85% corn silage, 15% distillers diet is where we saw maximum performance relative to RUP content. Out here at our highest level, it was 4.2% RUP as a percent of dry matter, and so that would be similar to about a 27% distillers grain supplement on top of the corn silage. One other really interesting point, I think, from this one of the trials, so on the one, it was about a 83-day trial, and so at the midpoint, we took a couple of days of body weights to see what had happened up to that point. So this is average daily gain. The red would be the first half of the trial, so basically the first 40 days of the trial, and then the gray here on the bottom is the second half of the trial, the second 40 days. The response to that RUP supplement was huge the first 40 days. So those calves came in about 600 pounds. That first 100 pounds of weight that they put on, and those first 40 days, critical that they had enough RUP in those diets in order to get the correct gain. The next 40 days in, we only saw about a 10% improvement in average daily gain as we increased RUP in the diets, okay? It was a 44% improvement in average daily gain the first 40 days. So we really think that the metabolizable protein requirements of those young calves at a lighter body weight first coming in, that's when formulating these diets is really, really critical for RUP content. So in summary, I think need to know what you're feeding and what the requirements of the animal are and match those two up, right? That's what we're always trying to do. So for corn silage itself, you need to know what the moisture content is, and you need to know how long it's been in the bunk in order to accurately decide what the RUP, RDP breakdown of the protein is within that. So we've talked a little bit about just what the crude protein of corn silage is, but you really need to then break it down into how much RUP you have, and maybe almost safe to just assume you don't have any RUP coming from that corn silage. Technically, we think the best number to use would be about 90% of your crude protein is rumen degradable. Then on the other side, the animal, meeting their requirements, really high metabolizable protein requirements for these calves that are less than 700 pounds. And those growing diets, those first 40 to maybe 50 days on these growing diets is when you really need those RUP sources. And to meet that RUP requirement, distiller's grain seems to work really well with corn silage. So for growing diets, corn silage really is an excellent feed, a good option if you have the capability of putting it up, as long as you formulate diets for MP. And really, we've seen gain with a very high corn silage diet, right? Anywhere from 3 to 4 pounds per day. So you can kind of formulate rations to meet whatever gain you're looking for. With that, I'd be happy to take any questions that you might have. Oh, I also want to always point out, most of the data that I presented would be in beef, all of it probably would be available as beef reports, and so all of those are available on the beef.unl.edu website. Any questions?
Questions?
Yeah. So the question, if I heard you, the question was about health of the animals. So with the RUP diets, especially here in these last ones I presented, as we increased the RUP content of the diet, was the health improved? Was that your question? Yep, that's a good question, and I don't think I'm able to answer it, to be perfectly honest. 120 calves, pretty hard to draw any conclusive information on health. I would say all of the calves were pretty healthy. I don't remember off the top of my head having any issues as far as having to pull them, so I would say they were all healthy. So I would have to say there were no improvements in health. However, that's an extremely small data set to start looking at health issues. And if we want to look at health, which would be important, need at least hundreds and probably thousands of animals to do that very well. So I hesitate to make too many conclusions about it, but certainly all of the animals on that trial were healthy. Adam.
Did you speculate on do you limit fed cattle? Because while gains are high and good, in reality it's probably not a good thing. Trying to push cattle to certain markets. Did you speculate on if you limit fed in those diets with higher levels of non-sparring food to maintain conversion advantage?
Sure. I always get nervous when Adam asks me to speculate. So the question was, maybe you don't want these high of gains. I understand that, yep, you're trying to hit target body weights or target windows with these animals, so you probably don't want these high of gains in some situations. So he asked about limit feeding the cattle on these diets in order to maintain conversions, but not have quite that high a gain. And so as you point out, it'll be pure speculation if I do that. The limit feeding experience we've had lately is with cows, and it continually amazes us at how efficient they become on these limit-fed diets. That's right. They have done very, very well on limit-fed diets, and we're constantly having to reduce how much we feed them, it seems like, because they keep gaining weight. We don't want our cows to gain weight, maybe, when we had them in the feedlot, and they kept gaining weight. And so I would speculate that on these diets, if you limit-fed, that they could do quite well, probably. I think it would be quite possible. It would take a little while to figure out exactly where you want to be, but I think it would be very possible to limit feed high corn silage diet, some distillers grains, to hit the targeted average daily gain that you're looking for.
Andrea, with the distillers grains in these diets, how necessary is urea?
All right, so Dr. Stock asked about urea in the diets. We've got distillers grains in there. Do we really need the urea? We tend to be conservative. I think a lot of nutritionists out in the field do as well. We put urea in there as a safety net. We know we're not RDP deficient if we've got the urea in there. Brad Boyd just did some finishing work, so that's going to be different than these growing diets, looking at urea in 10 to 20% distillers grains diets. Probably shouldn't need, our modeling suggests you probably shouldn't need that urea in there. And the data, to be honest, aren't perfectly clear. We did see a little bit of a performance bump at some levels with low 0.5% of urea inclusion. And so from the data we have, we're not confident saying you don't need that urea. Modeling would suggest a lot of times you don't, but it's kind of a safety net. Put it in there, and then you know you're not RDP deficient. These particular trials especially, where we're wanting to look at protein, we're wanting to look at these responses, we don't want to be RDP deficient because then we might draw inconclusive results from them because it's all about rumen degradable protein, which is not what we wanted to study at all. And so especially in these diets, we always put the urea in there just to make sure that we were not meeting any requirements relative to our DP.
Okay, let's thank Andrea.